Yeah.
Yeah, I was having issues with mine too.
I think I might just use mine.
Yeah, that's what I'm doing.
Okay.
Happening.
So actually,
Yeah.
in page 128, they have a table to tell you when you set one tail, when the critical value should be what? Okay.
What chapter is that?
Actually, it's chapter 9, but we talk about this actually in chapter. When I talk about this chart, I believe I talk about in when we do hypothesis test. So I kind of talk about this kind of early, and then so I thought maybe you guys kind of like forget about it. So.
Do you have a new book? Yeah, that's what I'm trying to figure out.
If you don't have books, it's okay. I'm just saying, I don't want to go back to PowerPoint to find that. So I'm just saying, let me find it. Let me give my phone is. So I want to make sure record this part. So if students not here, they still can hear the part. Okay, so think about one tail.
I think it's page 139.
Okay, different. Your old new book. If you have old book like me, we have a 128. A table like they tell you one tail, two tail like this.
Okay. Okay, so it's 140. I think.
Oh, you're in 140.
This.
Yeah.
Okay.
Yeah. If you are new book, I heard it's 140. If you are new book, you are old book 128. Okay. But so when you do the two tail, and of course your critical value will be positive, negative, right? Because you are testing both sides. But when you are testing one side, like one tail, okay, actually for the equation, you can decide, okay, you have a two group. I'm talking about question homework, okay. You have sample A, and then you have sample B. Okay, sometimes you can say group A, group B, right? And remember when we are doing the hypothesis, right? If you are doing two tail, everybody no trouble, you know, is you want to see mu1 equal mu2, mu1 unequal mu2, right? That is easy. And then when you set your alpha, whatever the alpha is, and your T critical will be positive, negative. So far, so good. Everybody get it. Only thing I can see is sometimes you find the wrong critical value. Be very, very careful. Okay. However, when you are doing one tail, okay, in this point, I don't care about you want to say which one is better than which one. Okay, but you have to be consistent. Okay, so for example, if you decide I want to test this group bigger than this group, okay, sample A is better than sample B, okay, then to avoid the confusion, you come to your research hypothesis first. Okay, you will say, okay, mu1 is greater than mu2 because I assume A is better than B. Okay, and then so here then you have be object, right? So then here will be say mu1 less than equal mu2. Okay, now after this, then you have to make sure your T critical is consistent. If you say this one is bigger than this one, okay, then according to your table, you have to be, critical value have to be positive. Right? Have to be positive. Okay? And then if you decide, actually, I believe mu1 is less than mu2, okay? I want to test. My goal is to see sample A, they are worse or the grade is lower than mu2. then this one will be greater than equal than mu2. Right? And your T critical have to be negative. Okay, now the issue is there. When you are negative, they are negative. You cannot change them become positive when you try to compare T obtained and T critical. Okay, because when you calculate your T obtained, they are follow the same formula, right? They are the same thing. Okay, so if I got our T obtained as a positive, if I got a positive score, but then my T critical is negative, what did you do? Or you got negative, but your T critical is positive. What do you do? Okay, so let's look at this chart. Okay, look at the chart. So if I set up is T critical here, right? So for example, 0.3107, for example. Okay, but you got a T obtained is 4.30. Then what did you do? I know, I see some of the answer try to ignore the negative and just say, oh, this number is bigger than this number without any sign. Maybe I should reject. You tell me. So if I got a positive, that means my T obtained is here, right? But my critical value is there. Even the number is some kind of big, but the sign is different. So what do we do in this kind of case? So it means original, I believe, okay, our mu1 equal mu2, right? And right now, actually, mu1 is really 4.3. It's here. Right? Right? 4.3. It's here. But then my critical value is there. I really want to know this, but actually it's here. Right? Because this one, 4.3 is here. Your critical value is here. So are you fail to reject or you reject? They had to be here to reject, right? But now they are here. You should fail, right? Right? Because it's not there. Even the number is so big, so good. You wish you changed the sign. You wish you changed the sign. Of course, you are doing homework, so if you go back and change the sign, change the whole direction, I don't know. But you have to be consistent. Okay, and on the other hand, if you set up positive and turn out to be negative, then what? You fail to reject. So I think it's easy to look at the chart. So if you say this, that means I assume mu1 equal to mu2, right? Okay, that's why my T critical value is positive. That's what I set up in this side. Okay, and if turn out to be negative, that means my original hypothesis is not matched. And it's okay. That's why one-tail test sometimes hard. When we do the real research, we seldom do one-tail. Because how do you really know which direction? So we usually just do two-tail. Just give yourself both choice, both options. So either this side or this side. And because you said positive, negative. But for the homework, because I want you guys to practice, so I have one tail there. Okay, so one tail, first of all, ask yourself, what's your hypothesis? Okay, I have two groups. Do I want to assume A is greater than B? Okay, If that's your hypothesis, that's fine. It's a positive. And then make sure when you got your T of 10, okay, they have to be over this positive sign to be reject. Okay? I open for questions. Hopefully I don't confuse you. But I think that's very good because right now we are really in the situation. So when we talk about this, it makes more sense. Okay? And if you confuse, that's even better because now you are thinking. Right? You are thinking because original we can, oh, easy, I'm just do this. You know, looks like hypothesis just a hypothesis. It's just a matter of formula. No. It's actually, it's logical thinking. Okay, so if you say this one according to this, if you are based on your research hypothesis, okay, your research hypothesis says this has to be bigger than this one. Your T critical, I want to see positive. Okay, if you say this one is smaller than this one, then I want to see negative.
Are you going to come up with the same answer either way? Like as far as rejecting?
The rejecting will be different because if you got a positive, then even the number looks so big, bigger than your critical, but the sign different. So original, you may think about rejection, but think about it. I live in Taiwan, you live in America. How can I take you? They are different sides of the world. Okay? And then if you said positive, but turn out to be negative, that means it's this. That means actually mu1 is smaller than mu2, and original you want to be bigger and actually small. So you should just fail reject because it's just like whatever you say in your non-hypothesis.
Okay.
Okay? Everybody got it? Got it? Okay. And of course, sometimes the question may be so obvious, you have to be one direction or another. Okay. But in this time, this point, I don't want to criticize for that. I just want you to decide yourself which one. Even the data is so obvious, sample B, the data is lower than sample A. Yeah. But then if you decide, you still believe mu1 should be greater, then you have to be positive. Okay? If you look at the data, you say, hey, looks like mu2 is greater, but actually in the what? mu2 is less, right? But if you decide this side, you put a negative, then your answer have to be negative, greater than, have to be far going here to be rejected. Good? Okay. I'm glad. Okay. So when I start to grade, I say, okay, should I continue or I should stop? Should I continue, stop, and I decide. One thing I can be lazy, so I say, okay, I'm just going to stop working, and I'm going to go back. And so you allow, okay, to fix it, but very carefully, don't fix it the wrong way, okay? If you already see, and don't come to ask me if you right or wrong. I don't want to do the job, okay? Ask yourself, based on this chart, okay? Doesn't matter which way you want to set up, just make sure they are consistent. Okay, and reject, not reject. Okay, and when you reject, remember another thing about P. When you reject, your P should be less. Okay, your P should be less than whatever level you set up. If you are failed to reject, your P has to be greater. Don't let me take point off. I hate it. The best homework I like to see is I can see, oh, correct, and I can just say, what the? If you are wrong, I have to write, I have to type. Oh my God, it's a lot of work, and I need to get heartbroken. Okay, so if you can finish and doing good, then easy for me, and you are happy, right? If I write a lot of words, I know you may be very angry and very sad, and then I'm heartbroken and you are crying.
I cry.
Right? I know. I was a student too. I know you're crying. Yes.
Are
Alright, how do you know the U's mu1 is less than or equal to mu2? Like, how do you know the U's?
How do I know?
Yeah, how do you know which hypothesis works for?
Okay, so actually for that question, I say lower is better. Okay, but then it's really depend on, you can look at some question very obvious, like last time we said play golf. Right, play golf, we want to them to be, the highest score is not good, right?
Yeah.
Right? So sometimes you can see, but if I just tell you simple A, simple B, I didn't really tell you much about, you don't really know. Okay, so in this case, you just decide, but from the data, you already see simple B data number is lower than simple A. You know when you subtract, they'll be positive. So you know obvious, mu1 kind of greater than mu2. You say, okay, so I'm just want to test, are they really different? Are they really bigger? I already can see it. You already see I'm shorter than Andrea.
That's true.
You don't need a hypothesis, I'm taller than her. You just want to see if she's really taller than me. Then not this. If this is Andrea, this is me. You already see obvious, she's taller than me. You just want to test, see if she's significantly taller than me. That clear? Okay, so sometimes from the data, if you already see the data have some tendency, that is one hit. Okay, and this in the question I give you very clear, I say, remember last time we have say sleep, right? Sleep less and sleep more, right? And we say sleep less, their reaction time is less. No, they spend longer time for reaction. Right? 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 In your turn, last time, we have sleep time, right? So we say, we have one group sleep very little hours, but our goal is to test their reaction. So we believe if people sleep very less, they will take longer time for them to react. So their immune will be higher. Then if they sleep so well, they react so quick, their reaction time will be less. Okay, so whatever you want to test, go to research hypothesis. Okay, set up your research hypothesis first. That's what you want. And then go back there to update that. But then your positive negative also come from your research hypothesis. Okay? And your T, after you get your T of 10, okay, then you compare with T critical. But then since you have different size, so don't just look at the number greater than, look at what your original is set up for the negative side. Now is T is positive. So what do you do? Right? If your sign is set up positive, and now you find that T of 10 is negative. They are in different side of world. You have no way to reject. Okay, and then go back to read your hypothesis. It makes sense. It makes sense. If I say my T is of 10, that means my mu1 bigger than mu2. Right? So if I think, okay, I can reject. But if mine is negative, that means this. But then looks like it's positive. It looks like it's this. Right? If I say negative, that means I believe mu1 less than mu2. But I got a positive, that means because they are mu1, subtract mu2. Right? When you do your T of 10, you use a group 1, subtract group 2. Okay? Question. Okay? And promise you won't cry. No, I mean, when you get don't cry. Cry is good. When you cry, that means your heart is still alive. That means you care. If people get not good, and they decide I don't care anymore, and they don't want to cry, then I should worry. Right? Then I should worry. So when you still cry, that means I still so care. I'm still confused. Okay? And when you are confused, you have more motivation. You want to know. And then when you want to know, you're more likely to understand. Okay? Good, kids?
Sure.
Better, right? Yeah, but don't pretend, okay? You don't know, don't say forever,
I'm
okay?
pretending.
What is the... They don't give me this? How do I erase my phone? I used to bring by myself, but then what is that? The reason I want to say this because actually chapter 12, chapter 11, we talk about repeated. You still have this. Even the sign a little bit different, but still the same idea. And then the chapter 12 actually it's go through all the three triple. Remember I said they are the brothers. So you still need to get a good idea. Okay? So I'm going to erase.
I'm gonna submit it anyway, girl.
I'm going to erase. Okay? Everybody good? Okay. So I think if you have a question, this is a question. I don't see anybody ask me, so I'm kind of surprised. Nobody asked me any question for this. I'm kind of glad, but then I'm kind of like, why
Have
nobody
you ever
asked
been so confused that you don't even know what question to ask?
Okay.
That's where I'm at.
Okay. That's fine.
Yeah, that's exactly what
I'm living in that world right now.
Yeah. So is this helpful?
Yeah.
Okay. So I point out, right?
I was wrong. I'm wrong.
Yeah.
You're wrong?
Go back and fix my
Yeah, that's good.
I don't know how.
I start to look at and I start to see, actually when I look at your homework, I kind of like you open a box without unknown. So I can start to see good, I'm very happy. And then when I suddenly see, good, please no, and I go back to see who is a student. But I'm not blaming you for whatsoever, okay? That just show my love, okay? Because I can give you point off, but you don't understand, you still don't understand.
Change my answer and watch it so wrong.
Seriously, I was probably right to begin with.
It is what it is.
But just because I say this, you don't have to assume you are wrong. Okay? Because I didn't tell who is right, who is wrong. You just go back to look through, and then also back to double check your T critical. Okay? Because, and then also check your calculation. Okay? See, did you get it? Because once you are wrong for the first T, then you are wrong for the second T. Right? So double check, because if you are both wrong, then my question is, do I take both point off, or I should take one? But then they are different questions, right? So then don't just to trust your calculator, okay? Double check, okay, and then see everything correct, and make sure your hypothesis. Okay, I start to see it's coming. You know, you guys start to write the hypothesis very good, step by step. I start to see that, okay? So then, big picture is good now, okay? Just a small detail, you know? Because once you guys move to another parent, right? To Dr. Hawaii, Dr. Victor, then they will come back to say, who is your mother, right? Right? And they start to say, how do you teach them? Why don't you tell them this? Then I can ask, sorry, I just love them. And they can say, you need to have tough love. Okay. So then I tough love in this way, right? Okay. So when we do this, you can continue to think about what we just talked about. It's similar. Okay, it's very similar. And also, when you are asking questions, don't wait until you get home. You should ask here. And when you ask here, you can ask very small questions. You can ask very stupid questions. Because when you are write down email, you kind of say, I don't know where to start it. But here, it's so easy. You just raise your hand, say, is that right? And chances are can be my error, not you. Can be my mistake, not you. Okay? So by asking, it's a helping both of us. Okay? Sounds good? And don't look down yourself. Okay? You are better than what you thought about yourself. Okay? You are greater than your thinking about yourself. Mm-hmm. Okay, so we talk about, they have 3 T brothers, right? Well, one simple T, okay. The way they set up hypothesis is different, remember? When you set one simple T, okay, let's go back to think about it. When you set one simple T, how do you set hypothesis? How do you set up? You have mu, right? And then what? And what?
Equal, not equal? I don't know.
Yeah, equal, not equal.
I mean, all of
Okay, and the number for mu, right? So the mu, so whatever, for example, they give you 76, right? Not 0, it's the nationwide average. Nationwide average. Okay? So this is for one simple T, right? So this is one simple. Okay, so for 2 sample, okay, then this time we use what? Compare both sides. And then, okay, so this 2 tail, if one tail will be what? Depend, right? If you believe your mu is bigger, right? Then this side should be less than, right? Or if you decide this should be less, then this should be this. Right? Right? So if you decide your group will be smaller than the national average, then less, then that be greater. Right? Right, the same idea. Then for this one, you'll be have mu1 subtract mu2, no, equal mu2, right? Or mu1 unequal mu2. So you compare 2 groups because you don't really know national average, and you don't care because that's not your point, right? And you want to see this, or you want to see one tail, right? Okay, then if you do now it's related. It's 2 samples, so this is 2 samples we say independent. So this is 2 sample independent T, right? Today we are talking about 2 sample, but then we call dependent. Okay, it say related, the book says relative sample T, and that's actually mean dependent T. Okay, and before we get there, let me tell you, so when we do this, okay, now we will use mu D. Mu D. That means the mean of the difference. Mean of the difference. Okay? And then so mu D, so mu 0 D. No, mu D, yeah, mu D. So one is equal 0, one is unequal 0. Okay, this time we use 0. That means when they subtract, this means difference. So when you subtract both pre and post test, your null hypothesis, they are no different. That means they are 0. we have same height. Okay, at same height before the school started or the end of school started. Okay, like little kids, right? They grow up very fast. So the teacher wants to know if I give them special food, do they grow higher or do they grow? Okay, and here say they didn't grow. Here say they grow. Okay, and of course you can also have one tail. You say, are they greater than 0 or they are less than 0? Okay, so you make sure you know they are triplet. I consider they are triplet, okay? But then the way they write the hypothesis and the formula, actually are different. Okay? Make sure, even they are triplet, make sure you know very different. You can tell, this is Johnny, this is Daniel, and that is Custer, because they are going to get angry when you mess them up. When you mess them up, right? They say, no, I'm number 1. No, I'm number 3. Don't mess me up. Anybody in your family have a triplet?
Thank God.
We do have triplet on campus.
Oh, really?
Mm-hmm. They are so cute. Okay. So I have oldest brother in my class, and he's very good. He's respond. He smile. He raise hand. Okay. So I really love him. Then I went to library for my another class, and after my another class, he walk in. Okay, he walk in and sit there, and I say hello. His name is Gary. Hi, Gary. And he looked at me and said hi. Okay, I said hi. He said hi. I said, what's going on? Is this student have a multiple personality disorder? Okay. So then the end of semester, I really cannot wait because that after semester I may not see him again. So I said, hey, when he turned in the test, I said, can I ask you a question? Why you act so different in library every time when I see you? He said, that's not me. I said, really? You are twin? He said, we have 3 of us. I said, oh, okay. So then you know me. I said, can I interview you guys? So they come to my office, 3 of them. I interview them. I finally know which one is which. And then the second semester, the second one, that one don't pay attention to me, come to my class, sit in the front, and even more active than his brother. You know, and then I love him as well. See, they are different people. They are triplet, but they are different. So you have to really know them individually. Okay? Because they're used for different function, used for different time. Right? This one used if you only have 1 group. Right? This one used if you have 2 groups and they are independent from each other. This one, they are 2 groups, but they belong to the same group of people. They just have 2 data, pre-post. That's why you say related. Okay, you are good?
No.
What do you mean no?
I said yes, okay.
Okay, but don't pretend. Anybody good? Everybody? Everybody? Okay. Everybody? Everybody? Your eye, now we cover our mouth, so I don't see your mouth, I see your eye, okay? So your eye is my source of energy, okay? If your eye starts going down, I'm going to start to walk like this. So if you see I lose energy, look, ask yourself, am I lose energy? Maybe, right? Okay, okay, I'm going to erase this. Don't you think statistics is so fun? Hopefully you love this.
I like SPSS.
Huh?
I like SPSS.
I don't like any of it.
Well, but
Same.
yeah.
I like SPSS.
But SPS you still need to understand. So SPS makes sense.
yes.
If you don't understand SPS, just SPS. It's just a computer.
You should give Andrea extra credit.
For what?
Because you taught us how to do it.
Oh. Well, let's see if it's right. Then we'll decide.
Okay. Okay. So relative sample, that means we also call what? Dependent. Okay? And then actually we also do the comparison. So this is just a word from the book, okay? So let's say same as independent, dependent T, okay, also called relative sample design. Also compare two set of score. But these two sample score is from same people. Okay, from same people or from matched pairs. You can say from husband, wife, from twin one with twin two. So you want to see are they the same. But most of the time we do the first part, repeat the major. Okay, so pre and post. So when you do thesis, you can do this too. You can do repeat the major, but you need to spend a little bit longer time for you to collect data. You need to give them about 2 or 3 months. It's easy. Some students, they do, my former student, they do, give students pre-test, and then show them video, and then give them post-test. They want to see if the video change their mind. It's a way to. Just sometimes one video, people don't really change it much. But that is also a way to do dependent t-test. Okay? Now, here we say most of the time we do this, we do pre and post. So when you see pre and post, you don't even need to ask yourself, what's this? You already know it's what kind of t-test. You see pre and post. Dependent T. Dependent T. Okay? And we call it within subject design. Okay, when we do independent T, we call between subject design. Okay? And then we do related, we call dependent T, it's within subject design. So it's pretty much compare yourself and you change. Okay, and you change. For example, I want to see before you have statistics. Hopefully, at the end of the semester, your hatred is a little bit lower, right? So that can be pre and post, right? Okay. Now, what's this? Okay. As with other tests, we will also compare our obtained mean. Okay. So we compare the mean difference, but here, sample distribution of mean difference. What we say in another chapter, we say sample distribution of different mean. So that the words a little bit reverse, okay? Because right now we care about their mean score. Are they different? So when we calculate, actually remember we say mu d. We say mu d. That means we subtract them before we do any work. So actually, I'm going to, and that actually is there. Okay, now, if you look at this formula, this compare the first brother and the youngest brother. Okay, compares one sample T and then dependent T. Because they are so similar. So look at this triplet. If 3 of them in front of you can see the first brother looks similar than the youngest brother. The middle brother kind of by himself. Okay, so did you see the similar? Mm-hmm. Very similar, right? Only difference is you use D rather than use X. So that means when you calculate, you subtract them first. You subtract them first and then use the same formula. Okay, so the first formula is sum of square. And then if you know the oldest brother, then you just use that, changing X to D. Okay, changing X to D, and that becomes your formula for dependent T. Okay, look at the second one. Are they look similar? Right? Now they look similar. The only thing different again is D. So make sure when you do your homework, make sure you put D there because that shows that you are doing dependent T. And of course, you can remember, if you still remember last week, last week, right? The formula for the second brother is much complicated, right? Okay, now this. Now this, right? Standard deviation. Okay, hopefully by now, when you see the formula in column left-hand side, you feel you meet old friends. And the one in the right column is the new friend. Okay, and they look so similar. You don't even need to really spend the time. You just knowing, you just replace your D to X. Then you already know the formula. Okay, how about this? Right? Steer. Right? You just need to have D there. And this. Right? So obtain mu, M subtract mu. Right? And that one you already subtract. Okay? Good? Feel what? Stressful, delightful, pleasant, crying. Okay. Okay. So let's practice this one. Okay. Actually, I don't know. Step 2 should be flying, but I don't know. I didn't set up that one. Okay. So anyway, so you have 2 data. Okay. And then again, when you see x1, x2, ask yourself, is this pre and post, or these are two groups? Okay. So you can see I have subject 1, 2, 3, 4. That means you have 4 people. 4 people. Okay. And then the pretest is 6, 5, 7, 10. Right? And then after is 8, 4, 9, 14. And then I tell you I want to do 2-tailed test. Alpha level is 0.05. Okay? So now, before we move on, how do you write hypothesis? Everybody just say it. Mu D, what?
0.
Equal 0. Or and mu D is unequal 0. Right? You are right. You are right. Okay? And then we set up the same way. Okay? But you see, even you look at 2 data, looks like you have 8 subject, but actually it's only 4. Right? So that's also part is very important. Looks like you have 8 subject, but they are same people. So the degree freedom is 4 subtract 1 is 3. Right? And then your alpha level is 0.05. Okay, now just important, make sure you find the right critical value. Okay, so it's a positive, negative, 3.182. Okay, so now what do we do? What do we do now? Guess. Be a fortune teller for me. What do I do? What I'm going to do next step?
Find the difference between before and after.
Yes. And the reason I show the slide later, because what? I want you to get used to write down this first. When you see the question, before you get your calculator, do the part. Do the part. Hypothesis, alpha level, critical value. Set this all up. Okay? And actually, if you are lazy like me, you can somewhere in your Word document already type it, so you can just copy paste, copy paste, copy paste. So you don't need every time find the symbol for mu for this, right? Okay, so then let's calculate. Right? And then this, usually, you use after subtract before. Okay, because we assume quite often we want the after have a better score than before. Okay? We want to see the difference. Even when we run SPS, we also try to do after subtract before. So that's why you see you got a 2, you got -1, you got a 2, you got a 4. Then when you add together, please care about their sign. Right? That's why 8 is 7. That's why 7, right? 2 minus 1 plus 2 plus 4 is 7. And then your mu D is 7 divided by 4. That's your mean score. That's your mean score of the difference. Okay? Then you square them. You square, so when you square, all negative sign is gone. All negative sign is gone. So it's 4, 1, 4, 16. So when you add together, it's 25. Right? So this part also important. Before you move on, make sure you got your calculation correctly. Okay, pretty good? Right? So far, so good, right? Okay. Now, step 3, you start to do the calculation and see, since you already finished all this, now just the matter of put into the right spot for your formula. Okay. Does anybody want to recall the formula? SD equal square root, and what's inside? Sum of D square minus sum of D parentheses square divided by n divided by n minus 1. Right? Right? Okay. Then you do this. This is just the matter of the calculation. If your calculation correct, you get 12.75 divided by 3 and this and this. 3.06. This is actually the standard deviation, right? Standard deviation of the difference. And then the next step is do the standard error of the difference. What do we do standard error of the difference? Everybody want to try? Tell me. So it will be SDM. SDM equal what?
SD divided by the square root of n.
Yes. SD divided by square root of the n. Very good. Okay. So 2.06 divided by 4 square root. And make sure you know it's 4. It's not 8. Okay. Because it's only 4 people. Okay. So 3.06 divided by 2 is 1.03. And it's not T yet. It's standard error of difference. Okay, now, how do we do T different? TD? Or we say TD of 10. How just T of 10. How do you do that? Huh?
The M.
Say louder so I can hear.
The M, I don't know, the mu, whatever that's called, the M, D minus mu, V of the SMDP.
Yeah.
I don't know the proper name, so I'm just.
What's the top? What's the top? What's the top?
MD?
Yeah, MD.
That's what you said.
Medical doctor. MD. Divide by what? Divide by what? What we just calculate? SMD, right? Right? Medical doctor divided by what? Specialist of medical doctor. SMD, right? So you got 1.75, that's from here, right? We calculate this one, right? And divide by 1.03. So we got this 1.70. Okay, now when you compare 1.70 to whom? To which one number? Who you compare? How do you make decision? Compare with T critical, right? And T critical is both sides, so we are okay for either or. Either positive 1.3182 or negative 3.182, and but it's 1.70. It's this good news or bad news. You have to be 3 something, either positive or negative. And now you got a 1.70, that's here, right? Right? Okay. So are we reject or fail to reject? Fail to reject. And because your P is what?
Larger than your.
We fail to reject, right?
Or alpha.
Right? And because your actually your P is bigger than the alpha level we set up, right?
Yeah.
Right? So when you reject, it's this.
Okay.
Okay. When you reject, no, when you fail to reject, it should be bigger. Okay? Okay? Right? And then inside is degree of freedom. Okay, P3 degree of freedom. You fail to reject, and P greater than 0.05. Okay, so when you fail to reject, you don't need to do effect size. You don't have to. Okay, but I'm still have that, so just for practice. Okay, the next slide I still have that. We just practice, but actually it doesn't make sense for this question because we already failed. Okay, but I just need to show you how to do it. So MD, absolute value, okay, divide by SD. Okay, now SDN is SD. Okay, so then you have this 1.75 divided by this, so you got 0.84. Looks like it's large effect, but we fail to reject, so doesn't matter. Okay, well, for your homework, I didn't really criticize the part. I say you can do for exercising, but I didn't really grade in that part. Okay, but for the real life, if you fail to reject, then you can save your energy. You don't need to do this. Okay? So is this brother cute?
No.
Yes, please say yes. Okay. Okay, then I still put this one. Okay, so now we have another question from it again from your turn. Okay, this one actually is one tail. The reason is one tail because they give you very clear. They say lower score reflect field stereotype. Okay, so actually they have a they try to see if education can reduce stereotype about mental illness. Okay, so they give the questionnaire to assess students their belief about mental illness. At the end of semester, they do again. Okay, and they want to know if after the class, if students start to, because they know more about mental illness, they were less likely to reduce the stereotype. Okay, so this is one tail, but they say low score reflect the field stereotype. So if you are the one doing this research, what's your hypothesis? Let's write our own hypothesis before I show the slide. Which one we want to test? Okay, make sure we put mu D. This will be 1/12 because they say doing 1/12.
So greater than or equal to 0?
It's fewer, right? So fewer will be what? When you subtract, remember post subtract pre. So are we doing less or are we doing greater?
Greater than or equal to?
For this one?
No, for HO.
HO. Okay, let's do this first.
Then it would just be less than.
It will be less. Because if you become less, right, then they can be even become negative, right? Okay, well, let's write down and see if she's correct. Okay, how many of you agree with her? Okay, how about anybody else? How about you? Oh, you're waiting. Any other? Okay. Okay. 0, right? Or the another side is this. Okay, let's see. Yes. My slide agree with you. Okay. So if they are less, that means when you subtract, more likely become negative number. Right? So then in this case, your T critical will be positive or negative.
It would be negative.
Negative?
Will be more likely to be negative, right? So whatever the number you put, you find that have to be negative. Okay? So we say, and the good news for this one is this. Hey, I put them lower in the subscript. I don't know why they come out like this, okay? They should be like very little d, not like MD like this. It should be M and small d. Not lowercase d, capital D but smaller, okay? I believe I do that, I don't know my PowerPoint can show. And then same thing here, SSD, they should be very small there. Okay, so MD is what? MD is represent what? Mean score, right? The mean score difference. SSD is what? Sum of square of difference. And they already calculate for us. Okay? So then our next step, okay, what is your degree freedom?
17.
17, right? 17. Okay, and then your T critical should be negative. Okay, and you know this number come from table 2. From table 2. Okay, anybody so far? So good. Okay. Okay, then the subtraction is easy, right? Because they already give SSD. So SSD, it comes from that sum of D square, subtract sum of D parentheses square divided by N, and divide by N minus 1. So then, no, so the top part, so you already have that one. So you put in and divide by N minus 1. That's your degree of freedom. Okay? Okay? And then you get a number. You get a number. Okay? Now, SMD is this number divided by N. Okay? And this number divided by 18, you got 0.97. Right? And now you just use your MD. Negative 3, okay, they are negative there. Negative 3 divided by 0.97, so you are negative 3.09. Compared with negative 1.740. Are we reject or fail to reject?
Rejected.
Huh?
Rejected.
We reject, right? Because they go over to your chart. right? We set up negative 1.740, then your score is here. Okay. Use this chart is easier because sometimes in the math, remember we say when you have negative, less is bigger. When you do the math, right? So it's hard to use the concept here. So I think if you draw the chart, then you will see where is the negative 3 following, and they are already go beyond your setting point. So then, are we reject or fail to reject? We reject, right? We reject, okay? Oh, where is my reject? Do I go here? Where do I say reject? Oh, here. Okay, so reject. And then your 17, okay, degree freedom, this. So when you reject, it's less. When you reject, it's less. Okay, I joking say that reject sign is less, looks like they're poking your heart. So think about somebody reject you, they broken your heart, poking your heart. Okay, you're crying. But actually in our practice, rejection is good news. Okay? Then you need to do effect size. You reject, you have to do effect size. Okay? Then must be, have to. Oh, looks like I forget to erase just for practice. You can see I copy paste the slide. Okay, so this not just for practice, this is real. Okay, so it's negative 3. Okay, so become 3. Okay, and then 4.10, right? 4.10. Make sure it's correct. 4.10. Okay, so you got 0.73, and then according to this, it's a moderate effect. Okay, most of you, pretty much all of you, very good with this, but make sure you give me the formula. Okay, don't just tell me 0.73, I don't know where they're from. I assume you know, but if you don't put down, I assume you don't know. Okay, so that's moderate effect. Okay, so easy, right? We almost done. Okay, just look at what's the advantage for repeat major. What's the advantage compared with independent T? What can be a good thing? Why sometimes when you want to do research, you want to do the dependent T test, don't want to do independent T.
Because you want to see if something is having an effect on something.
Yeah, you want to see something affect something. You don't want to see the difference.
Right.
And also, you don't need a big sample size. That's kind of good advantage. Okay, if you had trouble to really get a lot of sample, and you really want to know the difference, then dependent T test is a good choice. It's a good choice. Okay, field subject. But then, if you want to do this kind of research, you have to start early. Because you need to give the time for people to process. And so they are able to change, so you can reject your hypothesis. Okay? And then less variability, because we say if you get more sample, it's more likely you get more errors. You get a small amount, the error can be less. Okay? And you can see the over time how they change. It's very fun, though. It's very fun to see how people really change. Don't you think so? So that's why I enjoy to teach the program like this, because I can see how you change from the first day of graduate school from the end, the last day of graduate school.
You should do that math for us.
Huh?
You should do that math for us. Give it to us on graduation day.
Yeah. That's why I take pictures. I take picture, then your pre-picture, the post-picture, and then I say, wow, people change.
I was all stressed at the end.
But then I found actually I found this part of you. Because I found when I see students at the end of program, a lot of them work like this. They
taken
are
our
so
soul.
tired, huh?
You've taken our soul.
Yeah, they are almost done. When the flowers so blossom now, they worry about next step. And now you just beginning, so you still have a future here waiting for you. So you want to learn, because you still have a one year and what, four weeks?
Sound like that.
And then for them only have 4 weeks, so they kind of say, almost done, right? So different stages have different flavor, so it's good to see how they're different, right? Okay. Oh, still. Oh yeah. Now this is very fun. Okay. Why I have an A there? Why I have an A there? So I have Oh, that's why I cannot find my A. It's going. Okay. Now actually, this practice is not calculation. This practice is to see if you can recognize which one for which brother. Okay. So a study to evaluate the difference in math skill between 8-year-old boys and 8-year-old girls. You need to tell me, are they one sample T, 2 independent T, or dependent T? What's this one? So if you want to study, you want to compare the math skill between 8-year-old boy and 8-year-old girl.
One sample T.
2 samples.
I mean 2 sample T. Yeah,
2
sorry.
sample T.
I was like, just one?
What? Anybody agree?
Yep.
Yeah.
Okay. And then 2 sample T is also, we can say that independent T, right? Okay, so it's ID. Let's say easy way. Independent T. Why say ID? Independent T. IDT. Okay. Okay, how about this one? Okay, independent T. A study to evaluate the effectiveness of new antidepressant by assessing the degree of depression before treatment and then again after medication for 4 weeks.
Dependent T.
Dependent T, right? DT. Everybody good? Everybody clear? Okay. Okay, how about this one? A researcher is tracking the developmental components of walking by studying the same children at different age as they advance from sitting and support to crawling to balance to walking. Walking or walking. Maybe I just type
We
walking.
understand what you mean.
What I'm doing. Okay. Good thing this is a statistics class, not English class. Otherwise,
Dependent T.
okay. Dependent T. Dependent T. Okay?
How would that get set up though? Because he's going from sitting to this, to this, to this. So would it be?
Actually, they should be, if we learn more statistics, they should be repeat ANOVA, all that stuff.
Okay.
But then since we only learn dependent, independent T, so that just assume we only compare 2 of them.
Okay.
Okay?
Yes.
Now, how about this one? A college professor read that the advantage of amount of sleep needed by college freshmen is 8.5. She obtained a sample of 73 freshman students and compared their actual amount of sleep with the repeated report need for the population.
2 samples.
Huh?
2 samples.
You said 2 sample?
Yeah, in the independent sample design.
Really? Do we have 2 sample?
Well, because you would be comparing like freshmen with. Oh, I thought it gave you. Oh yeah, it's a. Oh no. Now I'm confused.
So what?
Oh god.
So
One sample.
1 sample.
One sample.
Because the average says 8.5 hours, and then professor wants to know if my sample, the student really sleep level amount of hours. So you use 1 sample here.
Okay.
Right? You don't have 2 samples. Right? But if we don't know this, and you want to compare if freshmen sleep more or sophomore sleep more, then use what?
2
In
sample.
2 sample independent.
Independent.
Right? Right? So for example, if I want to
And then if you give them drugs,
give them the drug,
then you compare.
then
the
you
difference.
pre and post. Right?
Yes.
You measure something and then give them drug.
Yes.
And then what? Right?
Got it.
Got it. Okay, how about this one? They want to see is visual or auditory, right? Different in memory. So you have a group, you only have them hear something. A group, you have them see something. And you want to compare. How much they remember? Independently. Okay. Do you know, based on psychology, which one is better? Hear or see it? Actually, they say if you can see it, it's holding less than if you can what? If you can see it, it's hold less memory than if you can hear. So here is important.
Really? Smell's important too, right? Isn't smell like one of the top ones, if not the top?
But of course, if you both is better. Both is better, right? Okay. But anyway, so use independent t-test to test. And I think this, okay. Mean level of anxiety for a sample of stay-at-home mom is compared with known population value of 50.
One sample.
One sample. One sample T.
Yep.
Do you think stay-at-home mom more anxious?
It depends. The kids at home with them.
Compare with, okay, so if you want to compare the anxiety level of stay-home mom and working mom, what kind of test you should do? Two samples. And which one you assume more anxiety? Working mom? Why?
Stay at home.
Stay home, working.
Because I feel like, well, like, I don't know, my rationale is with working moms, they have work anxiety and home anxiety.
Yeah, that's smart.
But stay-at-home moms have like more anxiety because
Yeah, but working mom have more like achievement from work
Freedom.
and freedom. At least those hours. Is anybody you are runaway mom right now? This
What does
moment?
that mean?
That's
Runaway
mean this
mom?
moment you are yourself. You are not mom.
Oh, yeah.
Then, so when she go home, she get more energy start to be a mom because she have some time for herself. You have time for yourself is important. And then the rest of you
I
all
didn't
still
know.
single.
Yeah, I gotta finish it.
Yeah, but I still believe working is somehow is better than not working. Yeah, I think about actually even students better than not as a student because you have a place to go, and you have something make you measure your achievement every day. Of course, then you say you put me down, right? But then you pull yourself up. That's also development, right? There's no free lunch, right?
So
if you want something, you need something.
If you took that same sample of moms and you swapped them,
Yeah.
would that be dependent?
If
Test?
if we have this and we add another sample,
Or like say you made the working moms stay home and the stay-home moms go to work. Would that be dependent? It'd be
You
like-
want
If
swap
you were
them?
comparing, yeah.
okay,
No, like mom swap.
Yeah.
yeah, and then you can add, you can do pre and post test.
Okay.
So measure them before they start to work,
Yeah.
right?
Mhm.
And then after finish your program,
Mhm.
then you measure their post test for both groups.
That'd be cool.
That'll be so cool.
Mhm.
So if you guys go to the create any program, you want to add statistics in, then people say, wow, you're so cool. You not only talk about how they change outside appearance, or just talk about feelings, you want to them to say they really significant difference. Very good. See, this is a good question. Anybody, any question? Questions, welcome. No. No, it means good news or bad news. That means you fully understand. Yes? Okay. Still waiting to digest.
I'm
Okay.
not thinking about homework 6 right now.
Okay. Okay, so let me shut down this one, and we can have a